Advanced Propulsion Centre is a joint venture between the UK government and the UK automotive sector. Our aim is to make sure that the UK stays at the very forefront of design, development and manufacturing of low carbon technology for application in the automotive sector. In doing this, we bring about high quality, high value jobs in the UK that deliver lasting economic impact. And beyond that, the products that are a result of our projects provide low carbon solutions for transportation that go all around the world.
In 2019, the UK committed to reach net zero greenhouse gas by 2050 to mitigate the effects of climate change. At this time, the transport sector had become the UK's largest contributor, emitting 28%. The Advanced Propulsion Centre accelerates the industrialisation of technologies that will help to realise net zero emission vehicles. At the Advanced Propulsion Centre, we are helping the UK industry to accelerate net zero technologies from research and development into production. This provides the UK with significant opportunities to maintain and grow its supply chain, both locally and internationally, while supporting the transition of the automotive sector to deliver products that fulfil the net zero agenda. The diversity of transport means that reliance on a single solution is risky, and that is why the Advanced Propulsion Centre supports a portfolio of projects that are technology agnostic, recognising that this diversity will be necessary to reach net zero. In addition to this, we support the move towards the adoption of a life cycle assessment approach. We see this as a key enabler for long-term decarbonisation of transport, ensuring emission from one part of the vehicle life cycle is not shifted to the other. We can use the experience from momentum from successfully reducing in-use emissions through innovation, R&D, and apply it to the whole life cycle challenge. There is a real opportunity to take a holistic view by working together to help revive and protect the planet for future generations.
During what has been a very disruptive time over the last few months due to the implications of COVID, the APC has been extremely sympathetic and supportive with the various projects that we're working with and the project teams. We've been supporting delays, extension, alternative payment methods, and different ways of working. I think, to sum it up, a sensible and pragmatic approach has been taken, which has been crucial to maintaining progress and not losing the great opportunities that the projects have got. We have found new ways to run assessment panels, allowing us to be more responsive to the disruption that COVID has brought about to our ways of working and to our customers' ways of working. We're now connecting with teams across the country from their home bases, and we haven't disrupted the flow of our competitions or technology developer program during this period. In July, we launched the ARMED competition, a fast response competition aimed at providing opportunity for industry partners to kickstart their innovation in times where perhaps their core projects were delayed or slowing down. This has also provided a chance to create demonstrators to show to headquarters and to other customers potentially what they can actually come up with and what they can do differently. What is the art of the possible?
The APC has made an impact. Since the launch of the Advanced Propulsion Centre in 2013, we have been at the heart of the government and industry challenge to reduce greenhouse gas emissions from the transport sector. In the first 6 years, our funded projects are projected to save over 225 million tonnes of CO2. That's the equivalent of removing the lifetime emissions of 8.8 million cars. These projects have also created and safeguarded 40,000 jobs. And we've seen the first signs of real positive impact on the UK economy, with regional increases in turnover and employment in the areas surrounding organisations who lead those core projects. It is an amazing start, showing that the receipt of funding genuinely helps to attract business, anchor jobs, and support the growth of regional communities. The APC is about more than just funding. Our core ambition is to stimulate R&D and investment in the automotive industry. And we do this not only through grant funding, but also by unlocking new potential opportunities. Our spoke communities represent over 600 organisations and 60 academic institutions, which help to leverage the UK's academic and industrial expertise. Our international events programme helps to open up strategic markets all over the world by providing an integrated UK platform at global events. We use insight and road mapping to identify where investment is needed to unlock new opportunities, mapping the UK's current capabilities with the long-term trajectory of projects and technology trends. And we operate an accelerator programme which combines industry knowledge, sharing insight mapping, business planning expertise to support technology developers on their journey.
The UK is great at R&D, from fundamental research in materials through to product technology and advanced manufacturing, leveraging strong links between industry, universities and research and technology organisations. And our track record in supporting R&D is great, but we sometimes lose out when industrialising these innovations at scale. We can be competitive, and yet we recognise that sometimes industry needs a bit of help to bridge into large-scale manufacturing. The transition to electrified vehicles is coming very fast, so the Automotive Transformation Fund, launched this summer through the APC, is designed to accelerate UK manufacturing investment for these new technologies with a programme of capital investment and late-stage R&D support.
Hello, I'm Zoe Hall, Head of Competitions and Projects at the APC, and I have the fantastic job of heading up a team that develop and deliver the core competitions, work alongside business development team to develop applications and follow the assessment process, and ultimately support the successful projects to deliver maximum impact as they head towards UK production. So the core projects supported by the APC have already delivered significant results, not only in R&D, but also in economic growth. The 16 competitions completed so far have resulted in 66 projects, and once concluded will total £1 billion worth of investment. The projects themselves are truly collaborative, with 206 unique organisations involved, representing OEMs, Tier 1s, technology developers, universities and other NGOs, of which 51% are SMEs. There is a variety of sectors too, including passengers cars to off-highway, and looking at a myriad of technologies and processes from batteries to hydrogen. They are also projected to create or safeguard almost 50,000 jobs, not to mention a host of new skills developed in a wide range of emerging technologies. And alongside this, they are going to save over 241 million tonnes of CO2. And what that means to us is the taking of the equivalent of removing the lifetime emissions of 9.5 million cars. So what are we looking for? So we're looking for projects that are going to deliver long-term capability in the UK automotive industry and its associated supply chain. Projects that support the UK government's Green Recovery Initiative to achieve zero tailpipe emission vehicles. Projects that are focused on late-stage R&D collaborative projects that will anchor further R&D into the UK, whilst also creating or safeguarding jobs. They must contain an SME, they must be industry-led, and they must be match funded. So firstly, what makes a good project? A comprehensive application is essential, one that sets out clear outcomes to be delivered by each partner. Best projects tend to be where the collaboration ethos was instigated at this application stage and was further respected and developed through the lifetime of the project. So, as Aristotle said, it's the theory of that the whole is greater than the sum of its parts. And this is further emphasised by continually evaluating that this R&D project that you're working with still aligns to the strategic vision of the organisations involved. And this is reviewed and sense-checked on a regular basis to ensure that everyone is maximising the maximum impact this fund and the project can get. However, we do recognise that times change, none more so than 2020. So the consortia needs to be adaptable and realistic, and the APC are here to support. One of the key factors to project success or failure is the project management, typically by the lead partner. This is not a commercial agreement, it is a collaborative funded R&D project. However, it is still bound by those same requirements: milestone completions, being on cost and being on budget. And this is across the whole project. So the APC provides support through our project delivery team, and they are invaluable, so use them as part of your team. And lastly, we go beyond projects and competitions. We have technology trends that look at horizon scanning and future impacts. We have the marketing and international events to increase your exposure to and then also our fantastic spokes network. So please make sure that you utilise the whole APC. So let me give you an example of a couple of truly successful projects. Firstly, let me talk you through Bowscale. So Bowscale was a project that was led by Hofer, and it was finished in the middle of last year. And it was focused on the design and manufacture of a highly advanced cutting-edge hybrid transmissions. And it was particularly successful for several reasons. Firstly, the impact of the project was impressive. Yasso moved to a new factory during the project lifetime and started production in 2019. Hofer created a new manufacturing facility in Solihull, and across the board they showed impressive job creation. From a project perspective, it was truly collaborative. It was a well-run project by an exceptional project manager. Regular communications between partners at all levels was key to its success, as was unambiguous reporting at quarterly reviews with clear targets presented for all the challenges. And talking about challenges, it was really key that everybody was informed so that there were no surprises and it could lead to quick resolution. So now let me introduce you to the second project, Flava. This was headed by Penzo, with Solvay as a key partner, supported by an OEM. The aim was to develop a modular, multi-material body-in-white structure for light commercial vehicles. And the reason why this was so successful was primarily down to the tenacity of those involved. The project started off as a very different project, but with the emergence of the last mile delivery vehicle market, they approached an OEM and the results speak for themselves. The project ended last year and they now have an automotive assembly facility that has enabled the use of carbon fibre at a price point that's achievable for fleet operators. The benefits are startling. Almost 50% increase in payload capacity, a 30% reduction in average fuel consumption, and a saving of around 6 tonnes of CO2 per van per year. Since launching, Penzo has received forward orders totalling more than £8 million and has in addition led the creation of 70 new roles within Penzo. Without the APC funding, that simply would not have happened. So let me introduce you to the SLEB 2 project. It is led by Equipmake, a pioneering SME based in Norfolk, focusing on innovative electric powertrains. The SLEB project is 1 year into its programme and is looking to support the challenges the bus industry face, creating groundbreaking, fully integrated electrical bus chassis. Due to the dynamism of MD Ian Foley, they have introduced an additional electrification opportunity in the form of a fire engine. A fantastic project we are extremely excited to see achieve and deliver in this market.
Hello, I'm Jasmine Bishop, the Business Development and Marketing Manager for Equipmake. And as part of an APC project, we are developing a cost-effective electric bus. Electric buses are one of the most effective ways to reduce the pollution caused by public transportation.
We believe there's a huge opportunity to improve urban air quality via the adoption of electric buses. To date, the barrier has been the cost, and we've taken that barrier away. Ultimately, our aim, which we have achieved, is to be able to sell an electric bus that is cheaper than a diesel bus over a 10-year period. The main issue with electric buses is the capital cost, and the main contributor to that are the batteries. So what we've done is reduce the battery size for a certain range by having a fully integrated thermal management system. Because the other big problem with buses is it can take as much energy to heat or cool the interior of the bus as it does to drive it along. So what we've done is a fully integrated control system to have smart control of the heating and cooling of the bus, which reduces the battery requirement And that means that the bus operator can get a day's range without any recharging, but with significantly less battery than before, making the vehicle cost effective. So within this project, Equipmeg's developed a completely new powertrain which uses our own high-performance electric motors onto a two-speed gearbox and a battery pack and control system. In this project, our partner is Agrale Argentina. They're one of the biggest chassis manufacturers in Argentina, supplying over half the market. Our initial market is in Buenos Aires with our Argentinian partner. They have 16,000 city buses and they replace them at a rate of 1,000 a year. So we're obviously starting smaller than that, but our objective is over a period of time that eventually all those vehicles will be electric. They've developed a chassis with us, so they've designed our powertrain system into their chassis, which is then given to a coach builder to build a bus. So what that means is a coach builder who has no electric vehicle knowledge can become an electric bus manufacturer.
What's more, the global market for electric buses is around 300,000 vehicles per annum, a figure that is only growing. But there has been one barrier to this, and that's been cost. Funded by the grants from the Advanced Propulsion Centre, the cost-effective electric bus project, or CELEB for short, has resulted in a fully integrated electric chassis that enables coach builders to produce electric buses without regarding any EV know-how. Over the last 3 years, Equipmake has led this consortium with one main objective: to take the bus to production. With in-service trials of our new electric double-deck bus and electric retrofit beginning in London, and our electric single deck starting in Buenos Aires next year. Our electric double deck will be the first electric bus in London up to the 2024 London TfL specification. We have developed the following items specifically for this project, which is a high torque motor, a brand new HVAC system, an ancillaries pack, battery packs and control system. We're scaling up to productionise these.
The UK REEV project is a light commercial vehicle development programme led by LEVC based over in Warwickshire. The project takes advantage of the innovative and proven electric powertrain currently in its electric taxi and have integrated this into a new lightweight commercial vehicle capable of ultra-low emissions. This vehicle is LEVC's first entry into the commercial vehicle sector and is aimed at meeting the needs of the automotive sector and UK legislative decarbonisation requirements, and will start production at the end of this year. Lead partner Hofer UK are developing modular inverter drive units and e-motors for high-power electric and hybrid vehicles. This project is helping Hofer build on their investments in an engineering technical centre and manufacturing facility here in the UK.
Hello, I'm Ray Collins. I'm the Managing Director and Chief Operating Officer for Hofer UK. The Hofer Group was formed by our CEO, Johann Hofer, in the mid-1980s. The group initially provided expert powertrain consulting services to the German OEMs, and the company grew and in 2014 moved into niche manufacturing. Now, With over 800 employees across 19 locations worldwide, we've developed into a global company. Our customers sit across a broad group, from bikes to commercial and off-road vehicles, and we're able to deliver either serial production products or complete systems. We can also provide systems, specialised engineering in multiple disciplines to support our customers' needs. Our systems comprise electric drive solutions with products both electrical and mechanical in nature. Our commitment is to provide our customers with access to a team with over 40 years of experience, which delivers to the customer's needed schedule and meets the requirements. Our team are adaptable and flexible and will always work with our customer to understand and offer the best solution should the requirements flex during the project. The UK business formed in around 2013 and has grown from a few people acting as a local sales force to 100+ employees across 2 sites. We now design, develop, validate and manufacture complex electromechanical products for the UK industry. The APC grant has enabled Hofer and its partners to unlock this UK business opportunity and will deliver a class-leading high-tech electric and hybrid drive unit for the UK. The partners started the project in December 2018 and the project is scheduled for over 3.5 years, moving from prototype concepts to production intent or C-sample representative parts. The lead element of the project is geared towards a PHEV application, and in 2020 we've seen amazing progress by the team. Considering the changes for all of us this year, the progress made in our new working normal has been astonishing. We've completed the system level assessments, which has allowed us to understand the motor requirements and have been able therefore to progress the motor design to a stage that we would consider to be advanced concept design. The inverter is high performance and utilises the latest silicon carbide power module technology. This gives the maximum package efficiency, and we've utilised the Hofer One board to deliver a design which is considered to be in the best-in-class bracket for power density. This has been achieved through a water-cooled power core. The transmission will be a high-efficiency, single-stage offset gear set and will incorporate splash lubrication design, which will avoid the need for a pump and any external cooler. This is obviously optimal in terms of weight and also in terms of long-term reliability considerations. Hofer will utilise a systems engineering approach to the EDU system, and we will drive the requirements for each of the products to ensure they operate as one optimised system. The system will go through validation loops as it matures through the phases of the project. The resulting product will then be tested as a system, which will validate the overall requirements or indicate the necessary actions to ensure that we align with the vehicle requirements. By undertaking system level test and validation, our aim is to minimise any risks to the later vehicle validation programme. We are massively grateful to APC for their ongoing support to our business and to other UK businesses. Thank you.
The Low CT project, led by CNH, is an exciting and potentially game-changing low-carbon solution for the agricultural sector. The specially developed tractor can also benefit from biofuel generated on the farm, which will release wider emission reductions and economic advantages.
The low carbon tractor uses natural gas, so it's a genuinely sustainable alternative to diesel, and it's a first in its industry.
So anything that can reduce the carbon emissions from vehicles is a good thing.
Cost saving that we can bring with this solution, a minimum 30% on average. This really is a game changer for our industry. In agriculture at the moment, we're experiencing a bit of an evolution, particularly in the area of technology. The farmer now is much more professional, much more business orientated, down to the running cost, the TCO of their machines. This is the first methane-powered tractor in the world. It gives the same performance as the diesel in terms of power, in terms of torque, in terms of drivability. The industry has to move from diesel. This is really something we can really put our hearts, our minds and our energy behind, we can bring to market.
The APC was very helpful to introduce us to some partners who had expertise, particularly in the heat management area.
The Zerkotech Group provide heat management expertise primarily to the automotive sector. We're a spin-out from the UK nuclear industry. The low-carbon tractor project gave us a real opportunity to get into the commercial vehicle sector. The partners recognised that the engine was going to run much hotter. Heat management, therefore, is a key to the success of the vehicle. And so there was a real synergy there between Zerkotech and the rest of the partners on the project.
We already worked with CNH Industrial, so when this came up, with our experience that we already have in thermal management, it was seen that we would be a good partner for this project. We already had partnership as well with Zerkotech, so we felt like it was a really good opportunity for us to get involved. It's of interest to me because it's the future of myself and children, grandchildren. It's something that we need to take into consideration.
So we developed the after-treatment systems to reduce the emissions from the diesel vehicles. And there's a lot of thermal management involved due to the high temperatures, and the environment that these vehicles work in is more challenging than the current on-road applications.
The APC's involvement was really key to helping us in developing all the processes and procedures that we had to do. They've got a very structured approach into project management, and they keep us definitely on target, on time.
I've been around high technology for most of my working career. This really sort of excites me.
It gave that feeling of the diesel tractor, and this was really like, okay, we have something serious now. It gives us possibility to attract the best talent to come and work for us here.
We wouldn't have been able to run with this sort of project as a small company without the involvement of APC.
I'm really excited to see where it's going to go in the future.
I'm really looking forward to being the one to bring this to market and to really execute the sales with the customer. A big step for the Basildon team to have this uniquely at this site, and really a strong signal that this will be the location where we'll manufacture the gas tractor for the future.
This leads me to where we are for 2021. So in order for you to plan ahead, you will see the dates for the future competitions for core, but we also support production readiness competition through the Niche Vehicle Network, a large focus on the new Automotive Transformation Fund with several EOIs and feasibility calls through 2021, and of course we have the continuation of the TDAP programme.
Hi, I'm Josh Dent.
And I'm Jeremy Clayton.
And we're here to talk to you about the Advanced Propulsion Centre's work with some of the UK's most exciting automotive SMEs. The APC fits into a broad landscape of support that is here across the UK to help technologies move from an early stage concept at technology readiness level 1 or 2 through to industrialised products at technology readiness level 8 and beyond. We run a number of programmes and projects, from strategic reports and industry road mapping through to really large scale R&D projects. But today we're here to talk to you specifically about our work with exciting and highly innovative small to medium businesses. In the UK, we've got a fantastic history of invention, creating new products and new processes. But early in the APC's life cycle, we recognised that it's actually really very challenging to break into the automotive industry and take those first few steps as a new or small business. So we created TDAP, our Technology Developer Accelerator programme, to help exactly with this issue. TDAP supports SMEs, be them startups, university spin-outs, or indeed more mature organisations, who have an early stage transport technology concept and want to accelerate their route to market. TDAP is essentially a structured early stage technology programme. It's a bespoke programme of support that we've developed around the key challenges of transitioning a great idea and taking it towards market entry. TDAP is slightly different to other innovation funding. Whilst, yes, the programme does support technology and product development, we take a focused approach to enabling participants to develop their businesses around their technology. Participants get access to expert automotive consultancy, mentoring and support to help them as they work through their programme and enable them to answer the right questions at the right time on their journey to commercialisation. TDAP deploys a gateway-driven process that selects only the best ideas at each stage to progress. So outside stakeholders know that TDAP-funded companies really are in really good shape. The programme is grant-funded, and participants are given access to over £100,000 of support for each one that goes through the programme. And you can think of this as either seed stage or pre-seed stage grant, or if you're a more mature business, you can think of it as innovation funding. Lastly, we utilise our APC network in the UK auto industry to make targeted and bespoke introductions to potential industry partners, but only when the time is right. We really emphasise that. So in a little more detail, how does the process work? We run nominally annual cohorts through an 18-month phased process. Through the phases of the programme, applicants work to, first of all, understand the best application fit for their technology, develop their target market, understand their value proposition, work on their IP strategy, understand their potential business model, develop a financial and investor plan, and then lastly, undertake a validation project, which aims to help them test their product as well as their business assumptions. And when applicants engage with TDAP, they're not just engaging with the APC's team. We work with a range of delivery partners selected for their experience to help enable the businesses to move forward. We structure their support over 5 work streams spanning market strategy, IP management, financial planning, new product development and networking. We've had excellent engagement in the programme over the last 4 years. We've supported technologies from new energy storage and management systems through to novel thermal control technologies, lightweight materials and even a couple of digital tool developers. These businesses have often been able to understand new routes to market and take a real, meaningful step towards their commercial goals. Typically, companies report a range of benefits from the programme. They often say that the participation in TDAP gave them a real credibility boost when talking to partners and customers. Successful partners typically develop their technology to a real TRL, that's a proper TRL of 4 or 5, and ready to take the next step on in their journey. Businesses report that they feel that they have been accelerated beyond where they otherwise would have been within the time they spend on TDAP by up to 36 months. And in the world of an SME, that is a truly meaningful boost. In terms of impacts, 28 companies have now completed the programme. Together they've leveraged over £14 million of investment and loans, and this is a growing amount. And on average, participants double their headcount following the programme, which of course is fantastic, but we anticipate that the major job impacts come downstream as these businesses move into their commercial phase. I'll now hand over to Jeremy for the last part of the presentation.
Over the course of the last 18 months, 10 businesses, shown here on the screen, were selected to progress through Wave 3 of TDAP. They have developed a wide range of technologies that you will hear about in just a moment. They've engaged brilliantly. Like so many other companies, they have battled their projects through this year's events with strength and determination. All have made fantastic progress towards commercial aims. We're so happy that some of these businesses can join us virtually to present their progress, and now we're going to hand over to some of these to run through their projects.
My name is Dr. Yura Sevchenko. I'm a rocket scientist at Reaction Engines. I have a PhD in combustion and over 15 years experience in the aerospace sector. I am the engineering project lead for HX Life Foils for Reaction Engines, Applied Technologies Division. The Applied Technologies Division was set up to adapt the innovative thermal management technologies developed over 30 years on the SABRE program for commercial sectors, namely the automotive, aerospace, energy and EV markets. Specifically for the EV market, we have developed technology which provides a step change in battery cooling called the Reaction Engines HX Life Foils. The HX Life Foils are a revolutionary thermal management system that can be easily adapted for multiple applications. They create an isothermal boundary which reduces the thermal gradient to a minimum. They are flexible, which allows them to be retrofitted into existing systems and easily integrated into future designs. They are also lightweight, which allows the increase of energy density across battery cells for a wide range of applications, as opposed to more conventional, heavier systems. By reducing the thermal gradients across packs, they facilitate significantly faster charge and discharge rates, thereby increasing the operational performance and life of battery cells. In real terms, this could enable you to charge an electric car in the time it takes to have a coffee. The APC, through TDAP, has allowed us to access external expertise, networks, and funding to further mature the project. This has enabled other sectors to benefit from this step change in thermal management. The next step on our journey is to work with partners to bring this technology to market and facilitate the uptake of electric vehicles in a more sustainable world.
I'm Bob Mustard, MD at Stalcom, and I hope this introduction gives you some idea of what we do and how we might help you in delivering your future projects. In lightweight structures, Stalcom focus on smart engineering solutions and use of advanced technologies with a focus on niche lean manufacturing, all around the core of experienced expert consultancy. Our structures are all designed from the outset with the manufacturing processes that we intend to use in mind. The latest FlexTech variable architecture delivers an affordable and scalable EV platform solution that can suit a variety of vehicle configurations. Stalcom won a place on the APC Technology Developer Accelerator Programme for two technologies. One is the interlocking extrusion system you can see here that allows us to create from a standard set of extrusions a interlocking space frame with very low investment cost, delivering lightweight and very quick to market aluminium space frame. In addition, the powder bond joining technique that was developed in conjunction with Powder Tech allows the aluminium extrusions to be coated in a specially developed powder coat that then allows a structural bond to be made between the aluminium extrusion and polypropylene glass composites. Stalcom's teed up R&D work has been carried out in the main at the moment by Dave Edwards, and I'm just going to let Dave say a few words about the where we are with that programme. Dave.
Following on from the powder bond work, Stalcom are now looking to characterise the polypropylene glass composite material called Weight Saver, which is truly structural. It's a unidirectional tape in a weave, giving quite a high strength. This material seems to show tensile and compressive strength quite similar to a medium strength aluminium. And using the powder bond process, we can laminate this into a multiple layer with aluminium sheet, giving quite an interesting combination of properties in the final material. So this is a prototype sample piece of a development base plate for automotive battery boxes. It's a weight saver polypropylene glass composite laminated with aluminium using a powder bond bonding process. And doing this, we can get much better properties in terms of weight and stiffness to some extent, and pierce resistance than a monolithic aluminium or metallic floor. And this particular combination of weight saver and aluminium laminate gives a final density of about 2 grams per cubic centimetre, which is about a 35% weight saving on a monolithic aluminium base plate. This full-size 3-layer laminate battery floor has now been constructed as part of the NVN supported PACES project. And this battery floor has allowed the battery box to be integrated into the vehicle structure, allowing greater weight saving.
Stalcom have extensive experience of taking many lightweight and innovative projects through into production. We have prototype and low volume assembly capability in-house and also help customers with implementing their own lightweight body structure assembly facilities.
Hi, I'm Roger Estrada, Managing Director and founder of R53 Engineering. R53 Engineering is a company specializing in high technology suspension systems. We're based in Warwick, UK, and we produce shock absorbers and suspension systems for high performance industries, the likes of high-end motorsport, high performance automotive, defense, and others. Our applications and client range from Formula E to other high programs in motorsport with McLaren, Aston Martin, Gordon Murray, etc. Our product range varies from different technologies like twin tube technology for applications for racing and automotive. We have other products like Formula E, as you can see behind me. And also we do products like for off-road vehicles, like this one here, which are much larger. And this product was designed and developed for the manufacture for the last Paris-Dakar race where conditions were really tough. In addition to that, recently, and with the support of APC and being part of the TDAP program, R53 is developed and patented a new technology, which is here, the first prototype, where we can adjust the vehicle height without changing or compromising the vehicle dynamics. This system is very compact and can be as a standalone unit or can be incorporated on any shock absorber that is existing on the market. The main applications for this system are aero control for better emissions, like roll control, and elegant egress, and other applications where you need height adjustment on the corner of your vehicle. And thanks to the great support of APC, R53 is managed to put this idea into a marketable product.
Hi, I'm Carolyn Hicks, co-founder of Brill Power. At Brill Power, we've designed intelligent control and management technology to help increase the reliability and performance of battery packs for both stationary storage and electric vehicles. So the electric vehicles and stationary storage packs are made up of hundreds or maybe even thousands of cells. These cells are connected in series in order to meet the voltage requirements of the packs. Imagine one 3.6 volt lithium-ion cell needing to be connected to others to meet 48 volts or 100 volts or even 800 volts, maybe even thousands. The problem is that in a regular battery pack, these series connections will be limited by their weakest cell. It's a weakest link problem. And there will definitely be a weakest link inside a battery pack. Even cells that are made to the highest level of manufacturing performance will have discrepancies in how they degrade from one cell to the next. It means that it will be difficult to predict performance, and the pack will be underperforming, performing at the value of the weakest cell. At Brill Power, we've come up with a solution to solve this problem. We are able to control every series connected cell or module within a pack through our game-changing hardware and software solution. We call it the Brill MS, a Brill management system. It replaces the battery management system that exists in current packs, but is able to control the current flow in a more optimized way. It's able to send more current to the stronger cells and less current to the weaker ones, meaning that we can draw every joule of energy out of every cell every time. The impact is significant. We think we can extend the lifetime of lithium-ion battery packs by up to 60%. Our customers will receive battery packs that are higher performing, more efficient, and even cheaper to make. We're currently working with partners in both the automotive and stationary storage markets. Please get in touch with us to learn how you can get more from your energy storage system.
I first started working with the University of Sussex in 2017. It was because I was interested in quantum technology, and I thought there would be a real opportunity to find some commercial potential as this technology was coming of age.
So the main difference in classical technology and quantum technology is really the performance of the, in our case, sensing system. So we can detect smaller signals than any classical sensor can see.
It was probably about 6 months in when we realized that there was a particular problem with electric vehicle batteries. When you look inside an electric vehicle battery, you're interested in the current flow. What we discovered was, by using sensitive magnetic field measurements, we could see that current flow. It was possible, without cutting the battery open, to work out what was going on inside. Our first opportunity to do some serious work on this was when we won an Innovate UK award as part of the Faraday Battery Challenge. What we were able to do was develop quantum sensors and use them to measure electric vehicle batteries for the first time.
I joined the company on a project that was working in collaboration with the University of Sussex, and that was really nice for me because coming from an academic background, I still had that touch with the academic scene, but it was working on technology that was to become commercial and have a real world impact.
It is very important for us to have an environment where there's a real collaboration between industry and academia, where the boundaries between the two vanish. And that is a very exciting way to co-create new science and technology.
We're developing a novel way of looking inside batteries. Our first commercial product is a magnetic field camera, and it allows us to put a cell inside that unit and get a live view of the current flow inside that cell.
The first measurements we took were in the laboratory using large equipment that couldn't possibly be taken into your typical research lab at an automotive house. We've been working with the Advanced Propulsion Centre to commercialise that technology. What we have now is all of the required electronics and sensors that fit into a single cabinet. We're now working with Empty Power to look alongside their formation and test process to try and understand more about the way the cells work and improve processes along the way. Up until now, battery researchers have relied on computer models to see what's going on inside their cells. What we were able to do is show them whether those models are correct. They can develop new models, they can develop new batteries.
What excites me about this is that it's new. No one has really done this before in terms of seeing the current flow inside a cell.
Having developed the technology, we needed to think about a way of manufacturing it. In the first instance, we worked very closely with the University of Sussex and used a lot of their facilities to prototype our designs. We've now got to the stage where we've invested in our own equipment and most of the manufacture takes place inside in our own workshops. As we develop testing techniques for batteries, we've also looked at the challenge of putting the same technology inside battery packs. What we want to be able to do is take what we've already got working in the lab and put them out there in vehicles, monitoring the batteries in real time. By integrating our sensors within a battery pack, we can measure the current in every single cell. This means if one cell has a problem, it's possible to isolate it. Any issues with the cells or their performance can be remedied immediately. This will improve safety and improve performance.
So there you have it. We're nearing the end of this video. We hope you have enjoyed learning a little more about the APC, our TDAP programme, and of course the businesses that have done so fantastically well through Wave 3.
If you want to know a little bit more about our programme, or indeed our organisation, or if you'd like to make contact with ourselves or the companies that you've seen presenting today, please find further information and our contact details on the APC's LCB stand. Thank you very much and goodbye.